Now, let's look at the definition of a function. Here is the statement. A function of f from a set D to a set E is a correspondence that assigns to each element x of D exactly to one element y of E. Let's look at this example. This example is that for each element 4, you input that into a box, and then it comes out another value 2. Okay, so in this case you have one input 4, you have another input output which is 2. You don't want to have 2 outputs for 4, okay, only one output. Now if you input 9, then you have a 3 comes out. If you input 16, you have a 4 comes out. So it looks like this box, the function of this box is to choose the square root of the input and give the output of the input values. So what is the function of this box? The function of this box is like a number machine, is to choose the square root of any input number. So that's the function of this box. If you input 1 here, it chooses the square root of 1, so it has 1. If you input 0, the square root of 0 is also 0. Okay, so the function of this box is to choose the square root, and that's the picture right here. For each input x, it has an output y. Okay, output is on the left, and then the function of this box is like choose the square root. How are we going to denote this kind of definition? We say, okay, the function of this box, so we use f, okay, shows the function of this box. And then the input, if it's x, so you put the input here in the parentheses and after f. Here the relationship between f and x is not a multiplication, okay, it just shows f is a function of this box, okay, and then the input is x. So this whole thing, after you input a value x, and then it process in this box, okay, after the function of this box, and then you have output y. So the output y is denoted by f of x. Okay, so it is read like f of x. And the f of x is actually radical x, because for each x you choose the square root. So that's why we write f of x equals radical x. Okay, so actually y equals radical x. And here there are some terminologies. We call this variable because it chooses all different values. So we call this variable is an independent variable. And then for each input 4, it has output 2, and then the value of y actually depends on x, what kind of values you input. So this value y, variable y, is called dependent variable. Sometimes in different books, x is called pre-image and y is the image. So we say 3 is the image of 9 and 4 is the image of 6. What kind of values can you input? Since this function of the box is choosing the square root, if you put negative number inside, it's not going to process it. Okay? So then the possible value you put in must be any value greater than 0 or equal to 0. And then we call this would be the domain of this function. And then what is the range? The range, you input all the possible values, it only chooses the square root. So all the outputs should be positive. So in this case, the range is also greater than or equal to 0. Okay? So then, let's come back to look at this. The terminology, the element x of D, okay, D means inside the domain, is called the argument of f of x. So you see here, x is actually the argument, okay, of f. It's not the, again, is not the multiplication relationship between f and x. Be careful. Okay. X is called the argument. And then the set D is the domain of the function. In this case, the domain of the function is greater than 0. Okay. Now, this is the domain. Then the element of element y of E is the value of f at x and is denoted by this. This is what we said, like here. Okay. So for this function, and then 3 is the value of f at x equals 9. Okay, so you may write in this case is example right here is 3 equals f of 9. Okay, and then that's actually radical 9. Everyone knows radical 9 is 3. So here there's something new, is you may write f of 9 equals 3. Okay? You may also write f of 1 is 1, and f of 0 is 0, and f of 4 is 2. Okay? Here's just the example. And then the range of f is the subset R of E consisting of all the possible values f for x in D. Okay, so here again, in this case, the range is greater than 0 or equal to 0. So you see from 0 and all the way up, 1, 2, 3, 4, 5, 6. Okay, so that's the meaning for the function. We'll see more example later about the meaning of the function. But anyway, here is the first example about the function. I'll see you next time.